Hello, today we're going to talk about finding the equation of a line of best fit. Alright, example number 1. So here we have a scatter plot with a line of best fit that's going through it. So the first question is, what is the correlation here? Well, it's a positive correlation. It's going up as the caffeine increases, the price increases. When they both increase like that, it's a positive. So what is the cost at 26 milligrams of caffeine and 75 milligrams of caffeine? So this is where you just have to basically estimate. So 26 is about here. We'll guess the 26 is about $1.55. This isn't the most accurate graph in the world. Say 75 is about $1.75 or something like that. And there you go. It's just about being able to read the graph right. If I said 300 milligrams up here, it would be about $3. So that's what drawing a line of best fit actually is for. It's for estimation purposes. So even though your data isn't a perfect straight line, you can draw a line of best fit through it and kind of predict where the data is going to go in a positive and a negative correlation. All right, here's 2 more examples about using the line of best fit finding equations basically. In this first one, you're just going to look at a graph and kind of figure it out. All right, so there's a bunch of scatter plots. You have a positive correlation. So which one of these, A, B, C, or D, would be the equation that matches up the most, or the closest to it? So it's a positive correlation. So this, when it's a positive correlation, you need to look at the slope. This has a negative slope, but this is a positive correlation. So this is not the answer. Any other one that has a negative? No. The next thing you need to look at is the y-intercept. The y-intercept is here. It's at 0.33 somewhere. But is it on the negative side or the positive? It's positive 0.33. So this right here would be your answer, just by simple deduction and doing nothing. Now this one over here we have to do a little bit more work on. So finding the equation of line of best fit is basically the same way you do anything else. So I could put some more dots in here if I really wanted to. That's fine. But I'm going to find it the same exact way that I always have. Or found the equation of the line. I have 2 points that are on the line of best fit. What do you think I'm going to do with it? I'm going to find the slope. So I'm going to take the point 0, 10, and 7, 7. You want to find ones that are actually on the line to help you out with this. You just don't want to pick 2 random points. So 0, 10, and 7, 7. There's a bunch of other points out here, but they don't go through the line. So do my whole slope thing. I'm going to do the formula just because I did. That's the way I did it on my paper. 7, 7, 10, 0. We get negative 3 over 7, which is negative 0.42, something around there, approximately. So now I have my slope. So slope is negative 0.4, let's just call it negative 0.4, just for ease. Now I already know what my y-intercept is because it's where it crosses. So y equals negative 0.4x plus 10. And there's my equation. That was just to show you do it the same exact way that you used to. Now if you don't have a clear cut y-intercept, if I didn't know that was 0, 10, all I'd have to do is just pick a point, plug it in there, and solve for b. Those are the 2 ways to do it. And there's my equation after the fact. Alright, now we're going to do it a different way. We're going to use the average method to find the equation of the line of best fit. So, I already have my data set up here. So, the first thing I want to do with the average method is split data into 2 groups. I'm going to try to keep those color coded. So I split it. I have 8 numbers here, so I split it 4 and 4. Did my first part, great job, pat myself on the back. The second part is I'm going to find the average of both groups, X and Y. So here we go, find the average. Find average of groups X and Y's. So here, to find the average, so this is the X of the first group. So I add all the X's together, then I divide by how many I have. 4. So 1 plus 2 is 3, 6. So 10 over 4, which is 2.5. Alright. Now I'm going to find the average of the Y points. So 0 plus 0 plus 0.1 plus 0.12. All over 4, because that's how you find the average. You get 0.22 over 4, which is, I have it in here, 0.055. Now I'll keep with this color, why not? The second group, I add up all the X's, so 5 plus 6 plus 7 plus 8, all divided by 4. That's why it's called the average method, you find the averages. So that's 15, 20, 26 over 4, which is, I already have it all written out, so it makes this easier. Which is 6.5. I could have done that in my head, those are my X's. And my Y is 0.12 plus 0.2 plus 1.5 plus 0.14 all over 4. So I add them all up and I get, well, I get 0.1525. Thankfully I already did all the math, so I don't have to pull up my phone this time. So, see, I'm going to put them into points. All right. So I have my X and my Y here. So my first one will be 2.5, which is that number right there for my X, comma, 0.055. My point here, my X point is 6.5. My Y point is 1525. There we go. We're on a roll. Then, the rest of it is how you always do it. I'm not going to go through it, just to save time. D, you're going to find the slope. You can do that by doing the slope formula. If you need to know how to do that, look at earlier in the video. And your last one is find y-intercept. Find the y-intercept, you take the slope, plug it in another point. If you didn't know how to do that, go back to an earlier video. And that is basically how you use the average method. So just in case you want to try to do this, for this whole thing, your final equation, so if you do the slope here, you'll get 0.024. If you do the y-intercept, you'll get negative 0.0035, and your equation is y equals 0.024 x minus 0.0035. In case you want to do it, to try it out, that is your final answer. Alright, this has been finding the equation of a line of best fit. Hope it helps. Good luck.